I'm a software engineer at WS02. I work in a product called Choreo, which is an internal developer platform provided by WS02. So today I'm very excited to talk to you about a topic that is very crucial for anyone who is trying to understand the complexities of modern cloud-native applications. Navigating the Kubernetes networking maze from IP pools to pod connectivity. In this session, I will dive deep into the fundamentals of Kubernetes networking, trying to understand how pods are communicating seamlessly within the Kubernetes cluster, and also how services involved in Kubernetes networking, and the major role played by container network interfaces in Kubernetes networking. Whether you are new to Kubernetes or you are someone who wants to deepen your understanding about Kubernetes networking, so this session is for you. So you know the snail mail or the postal service, where the postman delivers letters from house to house. So postal service makes sure that the letters are delivered correctly to the correct person, and also no letter is misplaced. So think that you want to send a letter to your friend in USA, snail mail still makes sure that the letter is delivered to your friend's house, although you two are in different countries. So how we are going to identify a house? It's by its address. So that's use of the house address. We deliver the letters for the correct house. So in a Kubernetes cluster, just like the letters, in Kubernetes cluster, we want to make sure that the network packets are correctly delivered within the pods. There can be clusters where hundreds of pods running, and we still want to make sure that communication between them are happening in a correct way. So in this example, this is a cluster. We have 3 different kinds of pods running. The front-end pods, where the UI part is implemented, and we have the back-end pods running, where the main business logic is running. And then we have the data layer pods, just like the MySQL, and which manage the storage, basically. So here, we want to make sure that front-end only talks to the back-end pods. And back-end pods are can talk with both front-end or data layer pods. How we are going to apply these policies, and how these pods are uniquely identified, how pods are communicating to each other. And these are some questions that come to our mind, and we are going to find answers for those questions in this talk. So let's look at the requirements of Kubernetes networking model. So pod is the smallest deployable unit in Kubernetes. So every pod should be assigned a unique IP address, just like a house in the postal service. And also, all pods should be able to communicate with each other, regardless of the nodes they are running. That's another thing. And the other one is, all nodes can communicate with all pods. So this is very useful when pod scheduling and performing health checks. You know, the pods are scattered in different nodes, and sometimes the kubelet in one node talk to pods in other nodes to perform health checks and so on. So these are the 3 main requirements of Kubernetes networking model. And then look at the pod networking model. As I said previously, each pod should be able to communicate with each other regardless of the node they are running. And the other thing is, within the node, we have one local network. So each pod gets IP address in one network. So pods on the same node should be able to talk to each other without any network address translation or net mechanism. That's another point. And the other point is pods are ephemeral. That means when a new pod is created, or restarted, a new IP address is going to be assigned. So let's look at IP address assignments for pods. So each node gets a CIDR, or the classless interdomain routing block, allocated for node. As you can see here, this node has got the IP address 10.24, IP address block 10.244.0.0/24. So what does that mean is, so 10.244.0 going to be constant over the node. So we have IP addresses like 10.244.0.1, 0.2, and 0.3. So now here we have two nodes. So here, as I said before, so each node has got their own CIDR block. So I here assume that you have some basic understanding about CIDR notation. So here, so you have in the right side, we have 10.244.1.network, where inside that, the pods have got IP addresses like 10.244.1.1, 1.2, and 1.3. And if you see the left side, we have the CIDR, that node is assigned a CIDR block of 10.244.0/24. So inside that node, the pods have got IP addresses in that network range. So just like 10.244.1, 0.1, 0.2, and 0.3. So the underlying infrastructure provider is responsible for allocating these CIDR blocks for these nodes. Just the cloud provider is actually responsible. So, okay. So here, what's happening when IP address is assigning for the pod? So the kube scheduler is running inside the control plane in Kubernetes cluster, and it schedules a new pod and notifies the kubelet, which is running inside the node. So the kubelet basically manages the pod life cycle. So it notifies, the kubelet notifies the container runtime interface, or the CRI. So the container runtime interface, or the CRI, is the API that we can use to talk with the container runtime like Docker. So CRI is responsible for doing all the low-level container actions like container creation, deletion, and so on. So when a new pod is created, container CRI creates the container and also notifies the container network interface to set up the networking interface for the containers. So here we come to one of the major part in Kubernetes network, that is CNI, or the container network interface, who does whole bunch of things to set up Kubernetes network. So here we can see when a pod is created, it is the one who allocates IP address for the pod from the node CIDR range. Then it sets up a worth pair and connects the pod's network namespace to the virtual bridge. And it also sets up a separate network namespace for the pod. So the pod's network names is isolated from any other. So, and another thing done by the CNI when a pod is created is configuring all the routing rules. So as I said before, so Kubernetes comes with a limited network support, and CNI does a whole bunch of things to enhance the networking performance. So if I give a definition for the CNI is a specification and set of libraries for configuring networking interfaces in Linux containers. Some commonly used network interface CNIs are Flannel, Calico, Cilium, WaveNet, like that. So there are main 4 operations done by CNIs: add operation, delete, version, and check. Add operation is done when a new pod is created. So when a new pod is created, as I said before, it allocates an IP address for the pod, and also it creates a virtual Ethernet pair. So I'm going to describe a little bit more about this factor. So virtual Ethernet pair or worth pair is a concept in Linux network that can be used to connect two network namespaces together. So with word pair, we connect this network network namespace to the CBR0, the custom bridge. So we know in networking, bridge is used to connect devices in the same network. It's just like a switch in physical networking. So with bridge, we connect these ports together, and we have two nodes here. So these two nodes are connected using a gateway. So gateway is basically used to connect two different networks together. So as I said before, the CNI also does this IP routing tables, setting the routing tables and all that. And that's what's done in add operation. And in delete operation, it reverses all the things done in add operation. So it basically deallocates the IP addresses and all that. So version operation is there to check the actual version of CNIs and all that. And also the check operation is there to check whether the CNI is configured correctly, the network configurations. So the network address translation. This is very useful to enable the communication between nodes. So actually the NAT maps multiple private addresses within a local network into a single public IP address before transferring data into the external network. So here, within a node, we have a local network. So when traffic goes out from the node, we apply these NAT rules. So with that, Kubernetes enables communication between nodes. So services, if I give a definition for the service, like a service actually, it gives a consistent and abstract way to access the pods. It basically hides all the back-end implementation from the client who is accessing the cluster. So actually, the Kubernetes network services provide stable networking and load balancing for the pods. You know, pods are ephemeral. That IP address of a pod can be changed anytime. But service has got a constant DNS name and an IP address that can be used. So that's basically the services. So there are 4 kinds of services mainly. So we have cluster IP, node port, load balancer, and external name. So the internal communication or the cluster IP. So under internal communication, we are going to look at the cluster IP service type. It basically exposes the service on an internal cluster IP address. So this makes that the service is reachable only within the cluster. So the cluster IP type of services enhances the internal load balancing and secure the access to the cluster. Okay, so external access. Under that, we are going to look at node port and the load balancer. So let's look at the node port first. So we know the ports are scattered in different nodes. The service should route traffic to those ports. So with node port, what we do is we expose the service on the same port of each selected node in the cluster. So here you can see we have the service, and from each node we have exposed the service with port 3000. This kind of services are very usable for testing, but can't be recommended to use in production environments because of the direct access. Other type is load balancer. So it basically creates an external load balancer in the cloud provider and assigns a fixed external IP to the service. So if the application is traffic intensive and like it gives high traffic, so load balance type of service is recommended to use. So service endpoints. So Kubernetes maintains a list of endpoints that match the service selector. So for example here, there is a service named foo, And we have a selector app:4. That means it's going to route the traffic only to the pods who have this label, app:4. So there are 5 pods, and 3 have this label matching. So we have the endpoints object. We keep it. We have the service name there, and also the port on which the service is running, and also we have listed the IP addresses of the pods which match to which the service is going to route traffic to. So these endpoints are used by the kube proxy to create the routing rules. Another concept which is useful in networking is ingress and ingress controller. So here, with ingress controllers, we can manage the external traffic to services within a Kubernetes cluster. So they basically provide a way to expose the HTTP and HTTPS routes from outside the cluster to services running inside the cluster. So basically an ingress is a Kubernetes resource that defines rules for routing the external HTTP traffic to the services within the cluster. So it includes information like host names, paths, backend services to which the traffic routed to. For example, we have here the ingress resource, and we have, this is example LAML, where we have set up all the routing rules here. So ingress controllers, as I said, with ingress controllers, we can fulfill those routing rules. So the ingress controllers should implement those routing rules in the cluster. So it's basically a daemon that listens to the Kubernetes API server for updates, and when there are changes for the resources, it updates the load balancer, reverse proxies, and all that to implement those rules. Okay, so as I said, in Kubernetes networking model, all pods should be able to communicate with each other. But it's not the case all the time that we need many times it's not the case that we need to block accessing some pods by some other pods, and we want to limit the access to some other pods. So with that can be done with network policies. So with network policies, we can deny all ingress and egress traffic by default, or we can allow traffic only between certain pods, and we can allow ingress traffic only from certain IP blocks, and also we can limit egress traffic to the specific external IPs. So that can be also done with several CNIs. So DNS in Kubernetes, with DNS service, we can basically map these service names into service IPs. So we have CoreDNS running, which is the default DNS server for the Kubernetes. It runs as a cluster add-on and provides a DNS name resolution to the cluster. So I built a whole story with IP version 4, but we know so as we progress, we need to support IP version 6 as well. So enabling dual stack networking will be must. So we can do that with the CNI as well. So with dual stack, we can the workloads have flexibility to use either IP version 4 or IP version 6, and also applications can incrementally migrate from IP version 4 to 6, and also dual stack networking enables IP version 6 only workloads to run when needed. So as I said, I work in a product called Choreo. So it is an internal developer platform. We extended our network with Cilium. With that, we could improve a lot in networking aspects. We improved our networking performance, like we could get transparent encryption with WireGuard, and also we could go to service sidecarless service mesh support, and we could improve our observability aspects as well with Cilium. So these are some few examples of the capabilities Cilium made possible in our platform. So but the point I want to make here is like selecting the correct CNI for your Kubernetes cluster according to your requirement is very crucial. So time is up. So I basically here talked about the basics of networking, Kubernetes networking. I emphasize the need of CNIs, how CNI plays a major role here, and how pod-to-pod communication is happening. And I talked general concepts that is used in CNIs, and sometimes the CNI's architecture is different from each other. Like the CNI architecture in Calico is not, it's different from the architecture from Cilium. So some concepts can be changed here and there as well. So if you need some additional resources, here it's there. And thank you. If you have any questions, you can reach out to me with these links. So thank you.
Thank you so much, Sumudu. She will be around, so you can, if you have any questions, you can just ask her. So Sumudu, please be on the stage. I request Chandra to give away the memento to her. She flew all the way from Sri Lanka for all of us, so please have one more round of applause for that. Thank you.